Flight, the magic power that lifts man above the ground into a third dimension of reality. A man's reach should exceed his grasp, said Robert Browning, or what's a heaven for? Always man looked at the heavens and reached for flight. Icarus, the legendary man who first dared to fly, was doomed, but the dream persisted. To almost everything man made, he gave imaginary wings, to ships, chairs, horseless carriages, as if he asked that they would somehow fly. But the forces of gravity were stubborn. An early success was reported by Alexander Graham Bell in 1896. I witnessed, he said, a remarkable experiment with Professor Langley's aerodrome on the Potomac River. It resembled an enormous bird soaring in the air. When the steam gave out, the propellers which had moved it stopped, and the whole, instead of tumbling down, settled as slowly and as gracefully as it is possible for any bird to do. Then two brothers, Orville Wright and Wilbur Wright of Dayton, Ohio, presented to the Commissioner of Patents a petition praying for the grant of letters of patent for an alleged new and useful improvement in flying machines. In December 1903, they telegraphed home to report success. 4 flights Thursday morning, all against 21-mile wind, started from level with engine power alone. Average speed through air, 31 miles, informed press, home for Christmas. Nothing, wrote John Dos Passos, can blur the memory of the chilly December day 2 shivering bicycle mechanics from Dayton, Ohio, first felt their homemade contraption whittled out of hickory sticks, gummed together with Arnstein's bicycle cement, stretched with muslin they'd sewn on their sister's sewing machine, soar into the air above the dunes and the wide beach at Kitty Hawk. 20 years before that flight at Kitty Hawk, a Frenchman, Louis Mouillard, predicted, when the first fear has been conquered, when the horror of empty space has been mastered through familiarity with it, intelligent man, after having reproduced all the gaits of the bird, will want to improve upon them. And he did. And a vast love affair developed between man and his flying machine. It was an age of heroes and heroic flights. Records were set only to fall and be replaced. records for speed, altitude, distance. Greatest of all, the record flight made by a young American in 1927. Paris, May 26, 10 o'clock struck. A sort of shiver went through the crowd. All of a sudden, the thousands were electrified by the sound of a motor. And turning, we saw, just as if thrown on a silver screen, a white-gray monoplane 20 feet from the ground and softly settling. A new age was born. A bird, Leonardo da Vinci observed, is an instrument working according to mathematical law, which instrument it is within the capacity of man to reproduce with all its movements. According to mathematical law, today the art of flying has become the science of aeronautics, as man studies the phenomena and the laws of flight, step by experimental step. To the first successful planes, only the barest theory gave birth. In just a few years, aeronautics moved to flight at supersonic speeds as research planes touched the dark edge of space. Test in progress. A flashing red warning light. A massive wind generator begins to turn. Through a labyrinth of pipes and tubes, a surge of air accelerates. In the test section, several times the speed of sound. Instruments sense the reactions. Forces, pressures, dynamics, temperatures, torrents of data. Computers store airplane designs as mathematical models, displayed on demand in various attitudes. Tiny currents race through a maze of circuitry. Research data stored, searched, and analyzed in milliseconds. The designer's imagination interacting with the electronic brain. In the creative dialogue between man and machine, successive steps are recorded by computer-directed plotting machines. Mathematical models translated into wind tunnel models of titanium and steel. The loop closes. As a concept matures, research aircraft add flight experience and verify the design, the interaction of parts during all phases of flight. The optimum compromise is the mature design. As aviation more and more becomes an inescapable part of modern life, research has turned to a broad range of problems. How to reduce jet engine noise. How to make runways safer. The turbulent wakes left in the sky by large planes. How to build stronger and safer airplanes. Shock waves and the sonic boom. Flight experience remains crucial. In various test programs, airplanes of many kinds are used to verify and improve design concepts. As our cities grow and expand, it becomes ever more difficult to get from place to place. In actual flight and in tests, concepts for short and vertical takeoff and landing are developed. Such airplanes may link downtown to downtown, city to airport, and town to country. Continent to continent, research programs investigate flight at ever greater speeds, ever higher altitudes. New York to Paris in 2 hours. New York to Tokyo in 6. Quieter, safer, and more efficient as time and distance shrink. Only a few decades since Kitty Hawk. The airplanes of tomorrow fly in wind tunnels today at 6, 8, 10 times the speed of sound. More and more people fly, more often, in more planes, to more places, millions today, tens of millions tomorrow. The greatest migration in history. The future of aviation, will it bring more crowding, pollution, noise, or will it bring us closer together into the family of man? Computers and wind tunnels, circuits and switches, dials and gauges, new tools for research, and man the designer looking into the future. Research today is solving tomorrow's problems to fulfill the promise of flight, a new freedom for man. A man's reach should exceed his grasp. The long, impossible dream to cross the threshold of space has become reality. As this mission unfolds, it carries with it the dreams of centuries, the science of 300 years, and a decade of experience in space flight. Sputnik, the first satellite. Then man himself, Yuri Gagarin, Alan Shepard, John Glenn, Valentina Tereshkova, a woman in space. Man walks in space. The intricate ballet of rendezvous and docking. Space, a new field for science. Sensors pointed at the Earth, the sun, the stars. Weather surveillance, communications, agriculture, Earth resources, and many other fields benefit from satellite research. Before man went to the moon, unmanned spacecraft made the voyage. Luna and Lunik, Ranger and Surveyor, camera shutters clicking from lunar orbiters to map the moon and select landing sites. In the long period of research and development that led to the landing on the moon, each step to be taken on the way and on the moon itself was carefully rehearsed. Here, men from the planet Earth first set foot upon the moon, July 1969 AD. It was a small step, a giant leap. They came in peace for all mankind. The astronauts found, as astronomer Fred Whipple had predicted, a sublime desolation. To this strange world, they came as explorers and scientists. There had been concern about man's ability to work in the weak lunar gravity, but the astronauts reported there seems to be no difficulty in moving around here, and we suspect it's even easier than the simulations of 16G that we performed in various simulators on the ground. Man comes to the moon with questions. Questions he asks of the soil, the rocks, and the terrain, of the things he sees and experiences and records. Questions he asks with the instruments he leaves behind. Information radioed back to Earth may answer age-old questions. What is the origin, the evolution of the moon, the Earth, the solar system? New questions arise. The moon becomes a laboratory. Scientists of many nations share in its discoveries. A sublime desolation, a laboratory for science. It is, in truth, for all mankind. As the astronauts return home to the sound of cheers and the music of a band. In laboratories round the world, the dream of the scientist comes true, to hold in his hands a piece of the moon. Konstantin Tsiolkovsky was a shy deaf school teacher and one of the pioneers of space science. Earth, he said, is the cradle of the mind, but one cannot live in the cradle forever. To leave the cradle, new and more efficient concepts of spaceflight are being developed. A space shuttle system, spacecraft which will operate in space and in the atmosphere, return to Earth to land on runways and be used again. Space stations will be scientific outposts in Earth orbit, platforms for instruments to survey the Earth and observe the heavens, and laboratories for the space technology of tomorrow. Teams of scientists and engineers will live and work here for long periods of time. Looking at the heavens, man asks the age-old question, is anyone there?
The reason for going to Mars really is to get on the surface of the planet, right? We're interested in how the planet was formed, where it came from in the first place, what is the physical environment of the planet,
and of course the biological.
And is there life on the planet? Does the planet tell us anything about where, how, when did life begin?
The voices of scientists, geologists, meteorologists, biologists mapping the exploration of another planet with Project Viking. An unmanned space probe landing on Mars, a robot laboratory to conduct experiments and look for life.
When you think about how to look for life, you do what every human being does who's ever been alone on a desert. The first thing he does, he opens his eyes and he looks around, and he looks, he looks with the experience that he's had for the length of his life. He tries to see if there's a shrub or a bush or a rat hole or something to give him some credibility to it. How about red grass?
But there's red grass on Earth, that's no challenge. Okay. The life detection experiment, it's really for experiments. And because life is such a complicated process, the more criteria of biological activity we can look for, the more likely we are to find it.
For example, there's the experiment that deals with photosynthesis, where you actually inject some carbon dioxide and see whether the carbon dioxide is picked up by the sunlight. But when people are introduced into an experiment, they're so simple. But think of the difficulty replacing the human in trying to make a robot, a machine that goes someplace and does something for us.
We're taking what are very simple laboratory routines, and we have to do all of this in a completely automated mode.
But the thing that really turns me on is the idea that there might be a separate and distinct origin of life on Mars. If you really had it happen twice in this tiny little sun solar system that we have, why, the universe must be teeming with life. And if that's true, who are we to say that we're the smart ones? We may be somewhere in the middle. One is always in the middle of some curve.
It's like the days of the Vikings, the real Vikings. It's an exploratory program, and new questions always produce more new questions, and this is how you learn.
And beyond this tiny little sun solar system, islands floating in the great void, is anyone there? Nebulae, clusters, galaxies, farther and farther. But where man has never been, and may in fact never go, his mind has already reached out to ask questions. Digital computers spin out data, gravitation, velocity, energy, mass, the life cycles of universes compressed into minutes. As man looks outward into the darkness of space and finds the light of new knowledge, he sees and begins to understand himself. Archibald MacLeish comments, "To see the earth as it truly is, small and blue and beautiful, in that eternal silence where it floats, is to see ourselves as riders on the earth together, brothers on that bright loveliness in the eternal cold, brothers who know now that they are truly brothers."